So now I'd like to introduce our next speaker, who's Francis MacDougall from Qualcomm. Francis is Senior Director of Technology at Qualcomm, where he leads the gesture technology development for next-generation TVs, tablets, and cell phones. Francis is a genuine pioneer in gesture recognition, having co-founded and been CTO of Gesture Tech, a company that was founded in 1986, and specifically to work on gesture recognition. So I'm very excited that Francis has agreed to be here and talk with us, because I really can't think of anyone better to talk about gesture recognition. And gesture recognition is one of these very broad sets of capabilities that we can use for lots of different things and lots of different applications. Francis?
All right. So we've got a ton of slides in here, so I'm going to go over some of them fairly quickly. But that'll just, they'll be available afterwards, so you'll be able to at least look at them then. So as Jeff mentioned, I was CTO and founder of Gesture Tech. Qualcomm bought my company 2 years ago, which was awesome. And they're a great company to work for. They're much more entrepreneurial than you would expect out of a 23,000 employee group, and it's a very dynamic place to be. So this is kind of an overview thing, so let's start with what is gesture recognition. And it's really part of a set of perceptual user interface technologies. They include things like face detection, face recognition, eye tracking, emotion sensing, lip movement, and speech recognition. Okay? Gesture recognition is in there. You can see that on the technology part of this slide that really vision is a key player in perceptual user interface, but that audio does come in there. And that in particular, gesture recognition seems to be being solved by a number of technologies. We're seeing ultrasound, dedicated sensors, and other technologies coming into play. Out of gestures themselves, there's several different types. So there are touch gestures, which we know the pinch gesture on the iPhone being a classic. Motion gestures, where you turn over your phone to hang it up, or perhaps just rotating landscape and portrait mode. Touchless gestures is really what we're focused on here today, and that's controlling a screen from a ½ inch up to 15 feet away. So a perceptual user interface architecture has to integrate all these sensors because they do support one another. In a good gesture system for a TV, let's say, you don't want an arbitrary hand movement to suddenly start controlling your device. What you'd like is the user is looking at the device, so you have face detection followed by eye gaze determination, then their hand becomes present, and so you can use these things to kind of support one another. So you've got to design your system to take into account that the sensors are going to be used by possibly multiple algorithms. So this diagram really shows that we've got 2D, 3D, possibly IR-based camera sensors at the bottom, some custom sensors possibly implemented, and microphones, and that they supply into different algorithm sets. And some algorithms are more important than others. So something like a really good face detection algorithm has to feed into the eye tracking, lip reading, face recognition, and motion sensing, and over to gesture as well if you're going to be doing the example I gave before. So it's really a nice integrated system, and you need to be thinking about how these work in a low power environment for cell phones and tablets and on TVs and other platforms. So now, why gestures? Why don't we just touch the screen? Okay. So one prime example is really the Kinect, which has shown us that a gaming and fitness application is not a touch system. It's leveraging the entire body. You can use it for a number of different activities, and we've really seen kind of this, I think, brought gesture into the mainstream for users. Okay? Some of the decisions they made on how to trigger an icon could have been quicker. They made some other issues, but in their second generation, you're seeing high fidelity, tracking, really nice sensors, and they are really driving the way for the full body apps. But for me, it's not about full body applications only. It's also about just generic user interface. How can we make these things so ubiquitous so that it's natural for you to use any display that you see with your hand? So I've got a little video here of an ad for the Samsung Smart TV that does incorporate gestures. So those TVs are in the public space right now. They keep updating them every year. They're even now shipping the control module as a separate component that you can upgrade. So you can now kind of commit to a nice display, but also have the ability to upgrade the core of the television. Some of the things you saw there, this is kind of an always-on system, so the camera is running continuously. When you do a little wave, you get an engagement with the system, so they chose the wave as their way of kind of ignoring everything else. Notice that a wave is typically aligned with the face, so you could use face detection to kind of make that a little more robust and ignore lower waves, etc. They also do hand position tracking for cursor control, and they do hand closing for click. Okay, so they can run it in a low power mode in general, where the camera is just waiting for that initial wave detection. Then they can run at full frame rate to detect everything else. We've also seen it launch now, though, on your major platforms. The Samsung S4 smartphone launched, and this was part of their campaign.
These ribs are insane. Hello?
Yo, Scott, what's up, man?
You gotta be kidding me. That's how you answer it? Call your phone with my phone. Oh, you gotta be kidding me.
Ooh, Tiffany texted.
Oh, I got it.
That was awesome.
Introducing the Samsung Galaxy S4. The next big thing is here.
So what we saw there is more what we call an event-driven system. So a call comes in, you can turn on your sensors at that time, so you're not wasting the power on them, every other time. And you're able to then do the call answer. So they have the ability to, detect a swipe in one direction, could have one answer mechanism, a swipe in a different direction could do a different one. The hovering is also really interesting, because when a notification arrives, her hands happen to have cream on them, she could just hover above it. And there's other use cases for that I'll go through as well. So the two things that they did, one is called air gestures. And for Samsung, they actually implemented a custom sensor for air gestures. So they're not using the typical vision sensor. They've got an IR emitter that they use. And that operates within about 20 centimeters of the sensor, and really just does right, left, up, down, and cover. Hover is actually operating within 2 centimeters of the screen, and I'll show what technology they use in a minute. So for the air gestures, you've got air browse, which really is used for stepping through, going back in a web page, stepping through a series of images, that kind of thing. Air jump, which is paging up and down. The call accept that they showed in that demo, which actually uses kind of a left-right double swipe, which I assume was because of robustness of the technology they chose. And then cover, or quick glance as they call it, which is something I use a lot. I have one of these phones myself, and it allows you to either bring up a notification the way they showed there, but it also can be used for bringing up an image on the screen when you're sleeping. You can just raise your hand towards the phone, and it just lights up a little bit, shows you the time, and then it goes back silent. So really nice, not having to find the button, press the button, that kind of thing feature. The big thing about hover is that it's starting to create a new class of user experience. And so what they're doing for, let's say you're going through your email app, you can drag your finger across the emails without touching each one, and you get all the data that's kind of hidden behind a click. So instead of having to click in and then hit back to come back, you just get it instantly. So in terms of efficiency for tracking through a large list, they're starting to really take advantage of the gestures over standard touch. And when you put it into a browser environment, again, you get this feature of mouse over that we're all used to on a computer that doesn't exist on smartphones. And you can just get highlights showing up on icons. You can zoom into things without even doing that. So I think one of the separations that Samsung is starting to do is to see that, hey, my hand is actually off the screen. I should have almost a floating layer in the UI that is off the screen. And so they're starting to implement that concept. We've got demos running where if you pull out a second layer, you can actually get the full email rather than just a précis of the text. You can also have multiple layers where if I engage this far, I get system level control. If I engage close, I can be controlling the app that's currently running. So a lot of things that we see as kind of enlarging your experience with the phone by not considering it just a 2D plane. It's now a 3D plane that you can actually interact with. Tablet use cases, this is primarily focused on the lean back use case. So something like where the guy was getting his face detected for the heart rate. And so in this case, media music control is really the main one we're seeing. So you can just pause your video as it's running and then play it again. So there's a few others that make sense. The screen orientation is interesting. You put a tablet on a tabletop, how many times has it flipped to the wrong orientation for you? And so there's no gyros or anything to help you with what is up at that point. So can I just put my hand above it and let it detect the orientation of my fingers? That's up. And you can also have multiple player or multi-user environments where you want to show it to someone else across the table, they just have to put their hand above it and it knows up immediately. Face is another opportunity there, but face tends to be out of the range of the sensor, so throwing your hand in there is a great idea. The other area we're starting to see adoption is in embedded automotive cases, and we've done several demos where the placement of the camera is actually in the kind of above the entertainment console by the mirror, rear view mirror, and you're able to do a lot of control over the GPS, over your entertainment console, over your phone system, and the idea is no-look control. And so very simple gestures where you might be just, I don't like that song, next song, that kind of stuff. So you can leverage inside the car. They have a sunroof demo they did as well where you could just put your hand anywhere and it'll go to that position. And human recognition, eye blink, all those other features are now being integrated into cars as well. So what gestures are really starting to be commercialized? So you saw in the Samsung S4, we had the near swipes. That's left, right, up, down motions, pretty close to the device. There's also far swipes starting to be used for TVs, etc. And that's really from 30 centimeters and further. Pause or mute, that's like the cover command where you just hold still over the device. Wave, the engagement that we showed on the Samsung S4. Zooming in and out, so that's something being used for images, for GPS, that kind of thing. Open palm, this is actually our preferred technique for engagement over the wave. We don't like really waving at the device. We like to just hold your hand up, have it respond instantly. It's a very unusual kind of, doesn't happen accidentally kind of hand pose. And so you can have it respond extremely quickly. Pointer control, I saw that in the Samsung. And below that, the click and drag. So being able to detect a hand click and a drag and a release. A circle gesture, kind of a rapid scroller, like an iPod scroll wheel, and being able to either change a volume signal very quickly or whip through a list of channels or whatever you're trying to control. You can do that with a series of swipes, but if you have 80 or more objects, just spinning it quickly is a much faster technique. And then actually detecting hand poses. Some companies have entire models built around pure hand pose detection, and with a 2D camera, hand pose can be solved. So it's a reasonable approach. So what hardware solutions are out there? So I've already mentioned 2D image sensors, and they're ubiquitous. Every phone has one, selfies being the proof, and you can leverage them with just software, so very low cost. 3D image sensors are starting to appear in more than just gaming machines. We've got TV companies that are using accessories that can come with a TV that can do some kind of play on the TV. We also see that changing dramatically. There's also hybrid or stereo triangulation methods like the Leap motion device. And then other sensors. So we've seen the one on the Samsung S4, the IR. There's ultrasound and there's near field imaging as well, which I'll go into. So in 2D sensors, the one problem you might notice is that the alignment is imperfect, and so it comes off the top of the device, so you kind of have a dead zone close into the phone and off at an angle, and your hand has to be a little bit higher than is ideal, but they're quite flexible. One weakness would be really a lack of true kind of Z depth that you can use. You can sometimes use the size of the hand effectively, and they work badly in low ambient light. 3D sensors solve many of those problems and are really an extremely powerful solution. They take you all the way to hand skeletonization in real time. So really your ideal solution would be 3D sensors. At the moment, the power requirement is your main kind of holdback on that. We're seeing, though, some companies launching in 2014 on laptops 3D embedded vision hardware. So I think this is going to come extremely fast. And then the hybrids. So something like Leap Motion has had a great success immediately. They have the main problem with them is the orientation of the device. So on a laptop where you have a mouse pad, it tracks the region above the mouse pad. That's great. On something like a tablet or cell phone, it's pointing towards the device and it gets confused by the face in the background and those kinds of things. So it has a limitation that way, but for the right use case, it's a very powerful sensor. And then now going to the lower cost, so we have a dedicated IR sensor really from Samsung here. It doesn't really get any Z, but very good at simple swipes. And then for the hover, we've got Synaptics and Cypress are the two suppliers that are kind of out there at the moment. It's really just taking projected capacitance and extending it a bit. So it's a little higher power utilization than a standard touch screen, but it creates that kind of zone above the screen, and we're seeing already some excellent use cases being developed for it. Ultrasound, Elliptic Labs is really the leader there. The nice thing about ultrasound is that it goes in all directions, so you're not limited to the space of your device anymore. You can actually start your gesture off screen and come across the screen, and it knows your entire path of your hand. So very effective for that kind of tracking. The one problem with it is that it uses a collection of microphones and emitters, and those microphones on something like a handset where the front face basically wants to be completely glass requires additional holes, so some of the industrial design issues are holding it back a little bit. And then electric near field imaging. So this is similar in performance to ultrasound in that it's aligned with the face of the display and gives you that kind of pro-cap feel. So if you wanted to take the finger touching the display and just keep pulling it back, this is a great technology for that. And so, because it's aligned with the screen. It goes up to about 15 centimeters successfully and does give you the Z and some pretty good accuracy. So this is fairly new. We haven't seen adopted in a full handset yet, but has some good characteristics. So if we take all of those tech and put them on the left side here, and then all of our gesture alphabet along the top, you can see which ones can really solve the entire problem space. And really the 2D cameras are solving it fairly well at the moment with the restriction of a dark environment and the problem that they take a lot of power. The 2D, the 3D at the bottom is the only other one that really covers everything. And I think the 3D has a superior advantage kind of longer term because 2D can handle a fixed pose, whereas 3D can give us kind of dynamic hand poses for real, more complex gestures. In some of the weaker ones, if you look at the choices Samsung made, they really had specific use cases in mind. So they wanted swipes, and they wanted the cover app, and so they chose one technology to cover that. And then they wanted hover, so they chose one cover for that, which gave them kind of the mouse control above the display. And because that was the three use cases they're trying to cover, they covered with kind of the lowest cost, lowest power solution, which I think was very wise. And then the rest of them, you see how they met out. Ultrasound really and near field imaging are not going to handle any of these kind of distance use cases, and they also are not high fidelity enough to detect, fingertips, hand poses, those kinds of things. The leap motion again has a limited range, so you can't get sort of beyond 30 centimeters, so it fails on these kind of two longer distance, but other than that is extremely good. If we look now, cost and power along the bottom versus fidelity and robustness. So you have the 3D hand skeletonization really being the cream of the crop at the top right, both expensive, uses a lot of power, has high fidelity, and is very robust. But those companies are aiming to bring these things into the mainstream, and so we're seeing, over the next 2 years, massive changes in that market. 3D hybrid is just underneath it. It doesn't have quite the flexibility, but does have high power and good fidelity. The 2D camera, I debated on putting it in the center of a cost perspective, or whether it should be really, almost zero because it's coming for free on the phone anyways. So, but from a fidelity and robustness point of view, it's about the midpoint. And then we get into ultrasound and NFI, being very close to one another in performance, with the NFI getting a slightly more robust and the ultrasound being a little more costly because there's the microphones in there. And then the hover devices is really just an extended cost on your touch screen, so pretty low cost. And then the IR components are almost like a towel dispenser system, so it's very low cost. How hard is this stuff? Well, it depends on your hardware. So if you look at that image on the bottom left, where you've got a complex scene and a hand that doesn't happen to be perfectly aligned vertically, then doing 2D hand detection on that requires a fair bit of processing, training, machine learning, et cetera, to pull that off. If you look at the right, you've got this raw depth map, and you could pull the hand out instantly as the closest object in the scene, or any number of ways to really isolate it. So depending on what hardware you have, the amount of processing that you require is very different. And on the above, you have the same issues with lighting. Trying to pull the hand out of that poorly lit image would be very difficult. Having slow exposures gives you all kinds of blurry images to work with, just increases your complexity. Whereas you add some IR to the scene, suddenly the hand is completely isolated from the background, simplifies the problem dramatically. There are several gesture issues that we are currently fighting with. I think some of the more interesting stuff is really some of the 3D hand skeletonization. That's really the problem that I think leads to the best gesture experience. And on the other side, it's really some of the low power issues. Now, state of the gesture market. So right now, we've got about almost $1 billion revenues it's $918 million revenues. 2013 is the kind of targeted. Now, we're including the Samsung S4 in that, Samsung TVs. There are several other mobile adopters, primarily in China. There's also Leap Motion and some follow-on sales by people at Xbox, the Kinect, that kind of environment. Okay? That scales to 2018 to over $7 billion. So we're really seeing a mass adoption of this. And not only in embedded devices, but also standalone devices. So we're seeing a growth there up to $1 billion for it separately for devices like Leap Motion. But in the embedded space, what we really see is how large companies are now really putting themselves behind this environment. Intel has spent about $100 million on their perceptual computing initiative to kind of spur growth in this area. They're working with a lot of partners, and their plan is to make gestures ubiquitous as the mouse and keyboard for laptops and desktops. And already they've got Asus, Dell, HP, and Lenovo placing 3D depth cameras right inside the bezel of laptops starting next year. So that's a massive kind of evolution for us. Samsung already committed to it. They're putting it on all their devices. They have TVs, cell phones, tablets, etc. And of course, Qualcomm releasing embedded gesture into all of our chips so that you can get them anywhere. So as a final statement, it took touch over 20 years to mature to the point that the technology was robust enough to track more than one finger at a time in a consumer device. 20 years. Once touch matured to multi-touch, the user experience of the iPhone emerged and really changed an industry. So user interface itself is such a part of our reality that it can make this kind of dynamic effect on a market. Gesture technology is rapidly maturing. This year we have these inexpensive sensors giving us left, right, up, down, and a cover coming on massive devices like the Samsung S4. It says in 2014 spring, we're going to have robust full 3D hand skeletons coming on laptops. So the acceleration in the gesture market is extremely high. Once you have that level of control, my position is the utilization of high fidelity gesture will be the basis of the next user experience revolution. Thank you.